I'm Braden.
Hi, I'm Quentin.
Oh.
Hi, I'm Caesar.
Okay, I'm Zoe. This is Lab 3, Colliding Constant Cars. We have 3 lab questions, and they are: can we use a graph to predict where 2 constant velocity cars will collide? What will the position time graph for a toy car look like? And what will it tell us about the velocity? So what we're doing in this experiment is we're taking 2 cars, one is slow and one is fast, and we're trying to use our physics knowledge to predict when they'll collide on a straight time, timeline.
So for our setup for the first part is we had a toy car and we replaced one of the battery slots with tinfoil so that it had less power going to it, so it would be slower than a regular toy car. We also used a metal track to measure the distance that the toy car traveled so that we could find the average velocity, which we found as 22.7 centimeters a second.
We measured the car's position every second until it reached 200 centimeters. Then we repeated that process 3 times, then found the average position of the 3 at each given interval of time. Then, using the average position in time, we found the average velocity of 22.7 centimeters per second.
In this graph, the red car is the fast car and the blue car is the slow car. We made lines of best fit using the slope and the velocity, and there are our lines. This is our prediction graph for when the 2 cars will collide. The black line shows the slow car and the red line shows the fast car. We set the red line at 200 centimeters with a negative slope, so it resembles what cars would do in the experiment. The lines are the average velocities of the cars, and with this they will intersect at our collision prediction. Our prediction is that they will collide just over 3 seconds at 74 meters.
So our procedure for part 2 is to time how long it takes the fast car to travel 200 centimeters, just to make sure that it's similar to the fast car from last week. And it took 4.4 seconds for it to go at 200 centimeters, which was similar to the last car. So after that, we lined up the fast car at the 200 centimeter mark and the slow car at the 0 centimeter mark, so that when we set them off and turn them on, they will collide. And we had a prediction for that. And we released the cars at the same time so that they would collide, and then we recorded the time and position of collision. We repeated that 3 times, and then we just compared that to our prediction.
Yeah.
I just, okay. 3, 2, 1. All right. 3, 2,
Wait, are you ready to time it?
timer ready? Okay. Are you ready? All right. 3, 2, 1, go.
Starting.
All right. 3, 2, 1, go. I feel like that.
For trial 1, it took 3.05 seconds to reach 68 centimeters. Trial 2, it took 3.10 seconds to reach 62 centimeters. In trial 3, it took 2.68 seconds to reach 69 centimeters. The average time of collision was 2.94 seconds, and the position of collision was 66.3 centimeters.
By looking at the slope, we got a close estimate to when and where the cars collided by using the data we collected from the cars before we actually collided them. This tells us that you can use a position time graph to predict where two constant velocity cars will collide. The position car graph looked like a straight line going through the first quadrant of the graph. That tells us that the car has a constant velocity. We have some inconsistencies in the speed because there was tinfoil in our slow car that would move when it drove, causing inconsistent speeds sometimes. There are plenty of others that could have occurred in this experiment. The two people who released the cars could not have released them at the same time, no matter how hard they tried. So there'll be a difference in the exact moment they were released, thus a different point where they collide. The best way to solve that problem would have been to use a programmed robot that would release it at the same time. And yeah, that's the end of our experiment.